going to take a look at interpreting expressions in context. So pretty straightforward, just kind of looking at the various different parts of an expression, what they mean when you put them into a context. So in this case here, first one here, a measurement of snow levels in a research station in Antarctica. When she starts the measurements, there's 15 inches of snow. It snows 4.5 inches per week, assuming no snow meltage, etc., all that sort of thing. Here's an expression to model this as 15 plus 4.5 W. So what does everything mean in here, right? So the constant, what is the constant? What does it stand for in terms of the problem? We know that our constant is the number that's on its own, right? So 15 is the constant here, right? And in this case, when we go back to our context, we've got 15 inches of snow when she started her measurements. So we've got the amount of snow when she started measuring. When Alexandra started measuring. So, you could say this in a variety of different ways, an amount of snow at the beginning, etc., anything like that. You interpret it, you can interpret it your way so long as you're sticking within the context, right? So what is the coefficient, right? We know that the coefficient is the number that's attached to the variable, so we are 4.5 here is our coefficient, right? That's the number, the factor that is attached to the variable, right? Some stuff about factors in your practice, right? So this is our term here, this 4.5 W has two factors, 4.5 and W. 4.5 is the coefficient, right? And what does it stand for in terms of this problem? It's saying that it snowed 4.5 inches per week. So it's the amount of snow that falls in a week. And I'm going to be specific about that and say, well, that's the amount of snow that falls in 1 week. And a lot of the time when you're trying to figure out how to interpret the coefficient, you could replace that variable with a 1 in parentheses and say, well, that's 1 week. That's the amount of snow that falls in 1 week. So what is the variable? We have a W for our variable, and it stands for weeks. Right? So this is as our weeks pass by, W stands for weeks. So that's our first example right there. We're going to power on and take a look at a few more examples as we go along. So our next example here, we have one more. We have the operator. The operator there is the plus. And why did she choose that? Well, our snowfall is increasing, and that's why she chose that. It's increasing. All right. Here's another example. Cost of apples and pears bought by any customer at Hannaford, 0.45 times A plus 0.65 times P. So what does each part of the expression mean in terms of the problem? So the 0.45, again, this is the cost, assuming A is for apples and P is for pears, which we've got to define here as well. You could say that the A is for pears if you wanted to. It'd just be weird. So we're going to say the A represents apples, and specifically it represents the number of apples purchased by a customer or bought by a customer. And we're going to look at that, the P as well, so the number of pears bought by a customer. So based on that information, we're now going to say that the 45, this is for one apple. Like we said, replace that with a 1 and you got it. So the cost of one apple, and this is the cost of one pear. So this 0.45 is the coefficient of A. This 0.65 is the coefficient of P. All right? And A and P are our variables. Moving on to another example, let's take a look here. Raffle tickets, similar idea, right? Again, we're defining, it looks like we're defining the variable T. We're defining that here in this case as the number of tickets purchased by a person, right? right? And specifically I say purchased by a person because it looks like there is a set cost for participating in the raffle as well as a cost per ticket. So to participate in the raffle, this is your expression that's going to determine your total cost. It looks like it's, I don't know, $5, 5 galleons, 5 nuts, I don't know, 5 units per ticket. So the cost of one ticket, and recognizing that we're going to be multiplying that times the number of tickets purchased. So that's the cost of one ticket. And the constant there is 3, and it looks like this is the cost to participate in the raffle. All right, so that's breaking that down here. Okay, feel free to pause. I'm going to keep moving on. Here's another example here, right? So we've got this math class, going to the movies. Again, we're assuming that T is for ticket and S is for soda, not the other way around. In this case here, we've got our variables. We can define them. We could do it whichever way we want, but I would suggest that we say that T is the number of tickets purchased, and S being the number of sodas purchased. Right? Recognize here that each member plans on buying a ticket and a soda, so I presume that this is going to be uniform right across the board, and presumably instead of using tickets and sodas you could just say people. But I guess this allows for somebody who chooses to not buy a soda. It also allows for somebody who chooses to not buy a ticket, but that, of course, would mean that that person is not allowed to go into the movie. But, well, okay, there we go. What are the coefficients and what do the coefficients represent? Again, we've got a 3 and we've got a 2. Those are our 2 coefficients. The 3 is the cost of one ticket, and the 2 is the cost of one soda. And the operator here is the plus, because, well, it's the amount. It's adding the 2 together. It represents that the sum of tickets and sodas, right? The sum cost of the whole lot. So moving on right down the board, we've got an expression here. And this one here, you can write any situation. Think of the questions we just looked at. First decide what your variable is going to be, and recognize that 4 is going to multiply times the variable. So the variable has got to be something that can change, whereas the 4 is something that is fixed, like a fixed cost of something, right? And then the 2 would be a starting point for something. Similar idea for these here, for this Harry and Ron question. It's the same kind of idea with this. Explain each part of it. Explaining each part of it, what does each of the different terms represent? So one term here, Harry, is the 6,000. The 6,000 for Harry is the initial amount. In Harry's account, and likewise you can say that 1,300 is the initial amount in Ron's account. The negative 240M, right? Recognize your sign goes with it, right? That's telling us that what this represents in this term here is that Harry's account decreases by this amount each month, and specifically any given month. So if we said that this was month 4, it would multiply it for us, and it would tell us the balance. Once we did the subtraction, it would tell us the balance in his account after month 4. And the same kind of idea with Ron's is just adding instead. So the variable M is the months. And I suppose this one here is open to interpretation. If you want to buy something that's 6,000 galleons, right? 6,000 galleons is the currency in Harry Potter land. We've got, if you wanted to buy something that's 6,000 right now, you might want Harry's account. But if you're content with saving up for stuff and being able to buy more things, you might want Ron's account. It really depends on the context. So give a reason. And there you have it right now. I'll leave it at that and let you take it from here.